Welcome to springlib.
Okay, so we're doing a mechanism problem here. We've got the following alkyne, and we're showing it react successively with HCl until we get a dichloroalkane. And so I'll show the step-by-step arrow pushing mechanism here. In the first step, the triple bond opens up to deprotonate HCl. And the HCl bond breaks with the electrons remaining behind on chlorine. I'll point out that I always draw my L's cursive, lowercase L's cursive in chemistry, just to avoid ever mixing them up with I's. I draw my I's, like this, my L's like this, my capital I's like this, and my capital L's like this, so they're never can be mixed up. So this is HCl. Okay. Triple bond opens up, grabs a proton. HCl bond breaks, goes on to chlorine. Okay, so the result of this is that we get now a double bond where we used to have a triple bond, and a positive charge is left behind. The other side got the hydrogen, but we don't typically show that. And we know we have a Cl minus left over from the HCl bond breaking with the electrons remaining behind on chlorine. And that chlorine will attack the carbon with the positive charge. And now we have a chlorine here. And the next step, this is going to look very similar to the first step. We get a new molecule of HCl introduced. The double bond now swings open to grab the proton. Okay. The HCl bond breaks again. Just as before, we're not going to show the H adding to the terminal carbon, but we are going to show this positive charge here that ends up on the other side. And just as before, we have a negative chlorine left over, and that will attack the carbon with the positive charge. And that's how we get to our final product.